HVAC 360, episode number 72. Melink Corporation. Hey, welcome back everybody to another episode of HVAC 360. I'm your host, Matt Nelson. This week we're going to be talking with Jason Taylor, who is a business development manager over at Melink Corporation. This is actually one of the few interviews that I did on the floor of the AHR Expo. I guess few is a little misleading. This is the only one I did on the floor of the AHR Expo. I've got a few others that I've lined up for future episodes, but this is the only one that I actually did. So hopefully it turns out okay. It's been a few, when it's a year between when you do these interviews on the floor of the AHR Expo, things tend to get a little bit adjusted. So hopefully the sound quality is okay for you. And I guess the one thing that really fascinated me, the one reason why I wanted to interview Jason in particular for Melink Corporation is the fact that Melink Corporation is focusing, and I'll let him try to do most of the talking on this, but just in short, they save energy doing retrofits on kitchen hoods. Now, you're like, kitchen hoods, what's the big deal? Well, kitchen hoods tends to be one of those pieces of equipment that falls through the cracks. You see, like if you were to do fire or smoke detectors, smoke duct detectors, it's one of those things it's provided by the mechanical, or it's provided by the electrical, installed by the mechanical. But in the same vein, this is something that may or may not be supplied or specified by the mechanical engineer. It may be somebody who, if they have a separate kitchen designer for the project, they might have them specify this piece of equipment for the project. And the same kind of holds true. There's this split between who's providing it. The mechanical contractor may not necessarily be providing the hood. They might have a kitchen a kitchen specialist actually providing the hood for the project, and the mechanical contractor is to connect the ductwork up to the hood, or he might be actually installing, receiving the hood, installing the hood, and connecting the ductwork up to it. So I think there's a lot of things in play when you're dealing with these kitchen hoods. A lot of the ductwork is, because it is grease laden, it tends to be, a heavier gauge steel. It's going to be, has certain fire ratings on it. It's going to be all welded. You might have drains. There's special things that go along with it that the engineer needs to think about. But I guess a lot of things that happen is, especially around the sequence of operation, and that's what really the Melink whole benefit is surrounding. It's that sequence of operation, and why is that? Well, really, it's one of those pieces of equipment. It's not the maintenance. It's not under the control of the building automation system. It's not under the control of highly or partially skilled mechanical the mechanical maintenance staff. It's one of those things that is actually worked by the kitchen staff. And when you put the control of such a energy intensive device in the hands of kitchen staff, they may tend to, not take it so seriously as far as energy savings go. They might, first thing they do in the mornings, they unlock at 6:30 and they turn on the hoods. It's just part of their pre-work checklist. They may not start cooking something until 10, but it's recirculating all this air and exhausting all this air, conditioned air. It's just throwing it out all that time. So it's really kind of important in certain situations where you actually take control of that a little bit, and that's why the Melink system, the Melink kind of solution, really fascinated me. So I'm not going to go over it too much. I'm going to let Jason do most of the talking. So here's Jason Taylor talking about the Melink kitchen hood system on the floor of the AHR Expo in New York City. All right, we're on the floor of the AHR Expo here in New York City, 2014. We are with Melink here, and I'm talking with Jason Taylor of Melink. How you doing this morning, Jason?
Absolutely wonderful. How are you?
I'm doing great. Hey, tell the folks about, in general, Melink. What do they do?
Melink got its start about 25 years ago in the HVAC industry through air testing and balancing, and through that process we've grown, and now we have a couple of products with IntelliHood and InGrid, as well as we do some solar. The IntelliHood is what we're here today on presenting at AHR, and the premises behind this was one of our owner was on the roof of a building, and he found himself cooling off over the exhaust fan, and he thought, hey, wow, look at all this energy loss that's here, and look at what we're losing. If you could harness this and contain it, look at the amount of savings you could have. So the journey began. He had to get some changes made to some of the current ASHRAE standards back then to allow this to happen, but through a lot of hard work, he was able to do that. The concept behind the IntelliHood system actually first come out in 1987. Several years later, in the early 90s, we produced our first product. That product received funding from a grant from the Department of Energy that further boosted it. It was RAM 1 was the name of it. At the time that they received the funding, they changed it to IntelliHood for a more marketable product, and we started kind of gaining traction, and we were able to create up to about a 70% conditioned air savings and a 90% fan energy savings, providing customers with a huge payback. The average ROI on the product is about 1 to 3 years. Where you find the product is in your commercial cooking kitchens and equipment, because currently what happens is those are they're not variable speed, they're constant speed, they run 100% of the time, and it's just, it's wasted energy when they're not cooking or when they're cooking at low standards. Some of the larger components of our system that make it what it is today, even with the evolution of the energy industry, is the fact that you have the optic sensors that are looking for the smoke, the temperature sensors that are looking for the temperature, and then the particular proprietary algorithms that are actually in the brains of the system to know how fast to run the equipment.
So essentially there's three components. There's the optical sensor that's in the hood itself, looking for smoke, looking for, make sure that you're cooking.
Actually, you have about 6 main components. You've got your keypad, which is how you interface with it, turn it on and off. Those are basically, once the system's turned on, the optic sensors are taking readings along with the temperature sensors, and they're sending that to your processor. So you got your optics, your temp sensors, your processor, your variable frequency drives, and then your air purge unit / hood controller. The purpose of the air purge unit is, you put optical eye underneath the hood. The first thought is, well, how do you keep the grease off of it? The optic sensor actually provides pressure into the box where the optic sensor is housed that creates a positive pressure so that the fluents and the grease do not infiltrate the optic sensor and clog the eye.
So I guess from a standpoint, do you see a lot of people specifying this on new projects, or is most of what you're doing now in the market, is that kind of a retrofit application?
Great question. So when we first started this process, we were really looking at new construction. And at that time, we did a huge amount of business with some of the quicker serve restaurants and some of the sit-down restaurants like Chili's and a lot of your supermarket chains. But as we kind of started to evolve through the years and we're really looking at this thing from an energy saving standpoint, we've now shifted to about 80% of our business is probably retrofit because of the amount of energy that is in the hotels and the governmental buildings. Your commercial buildings generally have hoods in them, and it's about the money, the energy that's being wasted currently. The standards are coming up to speed, so we do see a lot with new construction, and engineers are specifying every day, and we obviously are constantly growing that market, but it's also currently about 80% of our business. To go along with that, we also go to market through several hood OEMs. About 8 years ago, this was the only system because we pioneered it so far back. Now, there are other systems coming on board with the hood manufacturers, and we still provide our system when spec'd, and a lot of the engineers do that. But depending on what realm you're playing in, whether it be a quick serve type restaurant, there are other systems that they're not really so much about the huge amount of energy savings as much as they are about the operational standpoint of minimal energy savings.
So basically, what they're going off after the on-off kind of control, whether and it's kind of a binary yes no, as opposed to including a couple different sensors, and that's really where you see yourself separating yourself from the rest of the from the market that's kind of cropped up around you, is the additional sensors that you're putting in the package.
I guess our position is we know that the niche of the market we're playing in is to save energy. So whenever you look at that 1 horsepower, that 1,000 CFM single hood in a small restaurant, there's not a lot of energy savings to be had there anyway. Yeah, you want to make it more energy efficient, but where we really play is in the 8 to 10 horsepower and up market, where there's 3 to 5,000 plus CFM, and because we're modulating constantly, our price point is slightly higher than that market of DCB that's just temp only, but it's basically, we look at it like two different markets. You got your entry level market on quick serves or the smaller hoods. Once you get to that next level, this is where we play. We get asked a lot, well, why don't you just take the optics off of your system and do that? Well, we've got a lot of our own opinions on that, but a lot of it is just simply that we know that there's more energy to be had, and we can't be everything to everyone, and that the optics are required for safety and for a lot of other things to maintain those lower temp spans.
Now, I mean, obviously, you're supplying to the OEMs. The installation of these things, I mean, are you doing, obviously you're testing, part of your business is test and balance, so you're kind of in the contracting business. Are you actually going out and installing installations, or do you use other contractors to do that, or is it a combination of the two?
Glad you asked. So with that, what we actually do is we actually have a combination of that now. For a great period of time, we did everything turnkey on our own. We did all the programming and the commissioning and startup. Now we have started shifting, but the caveat to that is that these contractors that we use are still very closely connected to Melink, and they have to be certified. And there's different tier levels of certification that we allow. The highest level of certification would be a Tier 1 contractor, and that basically means that we can ship those guys smarts and parts, and they have the ability and understand the system well enough to do the final programming and provide us all the documents to certify the system and make sure that it is per a Melink standard in terms of what the end customer is receiving. We generally, from a quoting standpoint, we're quoting a turnkey process, and we're divvying up internally, deciding who the contractors we're using, so that we keep a tight pulse on the quality of the product. But to answer your question, yes, it's a combination the way we stand today. We have reps and distributors, a few in the United States, but we also have them in Europe and spread out in Asia and some in South America.
So when you go to these manufacturers, how do you, or not manufacturers, but restaurateurs, people with the kitchens, I guess how do you justify what's the sales pitch? How do you know that they're a qualified person? I mean, you said that there's a limit to whether or not it's a large enough hood, but I mean, how do you kind of qualify whether or not they would make a good prospect?
So basically, the process that we take with that, we're kind of steering away from any of the quick serves restaurants. You kind of mark them off. There are some that are viable projects. However, more than likely, you're going to be looking at your sit-down restaurant because they're going to have a lot more cooking going on. Rebate programs, that's the other thing. This system has a lot of rebate initiatives depending on where you are in the country, and that helps drive the end user on the restaurant. We know that the restaurant owners, if some are involved with energy savings and they really want it, and some do it out of necessity because they've got such high energy costs, and others, they don't want anything to do with it. But our basic approach when we walk in is to gather just enough information to get the horsepower and the size of the motors, the length of the hoods, and the voltage and maybe their energy rates. We basically take that data and we put it into what we call an estimated savings report. And this is a third-party report that basically creates what your expected savings is to be off of your building size. From that, whatever that customer's threshold really is what drives that. We then present them and say, hey, this is the amount of energy you're going to save with your energy rates. This is basically your return on your investment. How, is this something you want to move forward with?
Now, when you talk about these estimated energy savings, this is something that is it conservative? Or do you kind of verify savings after you do the installation? How do you work that?
Well, kind of all of the above. So, with our system, we've got over 10,000 systems installed. We know because of those 10,000 systems in previous reports and verifications by people like Don Fisher with Fisher Nickel with the Food Service Technology Center out in California. We know that we conservatively can claim a 65% minimal run speed, and that is where our savings report comes from. Now, there are plenty of systems that are out there running in the 52% average run speed, 54% average run speed. Because of our experience with it, we know that certain industries may actually creep up a little above that 65%. So it is a combination of the scientific equation along with the fact that we've got so much experience in the industry, and we take the approach that we're always going to be conservative. We never want to oversell and underdeliver to our customer, so we always say that conservative approach. The verification process, what happens is because the system is able to log data. We have customers where they say, hey, we want to do 4 systems to begin with on these 4 sites. We want to log that data, and then we'll use that to move forward. We'll go in after the 4 systems over a period of time. We'll pull that information back off, look at the logging trends, figure out what their actual savings is, and it normally exceeds what we had estimated. We're pretty good at the estimation process just because we've got a good understanding of what outside factors affect the system. If you've got, and it also helps us find issues internal to that customer system. If we're seeing really high run times on that, and we know that setup shouldn't do that, we can go back in and look and say, hey, you've got pilot lights that are that need some maintenance, or you've got some airflow issues, or whatever. We can point those out too because we know about what it should be running.
Now, we've been talking primarily about restaurants, those type of things. How is the fit with more of an institutional? When you talk about, schools, talk about different higher ed, any sort of special cases like that. institutional healthcare, those type of areas.
Yeah, excellent. So, like as we talked about earlier, the first thought on the system was designed off of a restaurant, a sit-down dining restaurant. Well, through the evolution of the system and the 10,000 installations and our evolution with the industry, we learned that there's probably 80% of that business that we do is in the institutional markets, all that you just named, whether it be K through 12 schools, whether it be universities, prison systems, governmental businesses, corporate buildings. We're in all of those, military bases, anywhere that you really have larger amounts of exhaust with added horsepower, and the longer run times. Some people, a lot of times we get calls and they say, well, my run time's not that long. I only run about 8 or 10 hours a day. It depends really geographically where you are in the country, because you can be in the Northeast and that's going to be a quick payback of 1.2 years. If you're down south, in, say, Miami, it's still going to be an acceptable payback, but it may be 3.5 years. So a lot of that, the markets that we play in, we're really a very broad spectrum today, and it's driven by the demands of the ventilation systems on the sites. A lot of these schools now are becoming more green and really looking ahead to the future of what they're teaching the kids. So they make the initiatives as well to make sure they have the greenest system possible.
Now, as far as ROIs, is there a certain range that you like to shoot for on the return on investment?
Yeah, so our average ROI is about 1 to 3 years as an average on the system, and it depends on where it's at. There are factors when you're working with some of the larger buildings, whether it be government or corporate, to where those have maybe a little longer 5 or 6 year payback, but generally those are what we consider to be what we call a legacy building. So it's going to be around 25, 30 years, and they're not going to have a change. So it's an acceptable payback. Like I say, 1 to 3 years is the average on the payback.
Now, you'd mentioned that all you need is some simple kind of variables as far as horsepower, size of the fan, things like that. If I'm an owner, if I'm a contractor looking to provide some added value, if I'm an engineer or energy auditor looking to try to identify things that are more low-hanging fruit, is that a service that you offer? If they just, hey, there's a form you can fill out, send back to us, we'll say yay or nay. Is that something that you'd provide?
Absolutely. So with that, what we prefer is that there's actually a web inquiry on our website at www.melinkcorp.com, to where you can actually send in an inquiry. Then one of our business development persons or an engineer will get back in touch with you, provide you with that short form survey, and that so starts the process, to where from there we will basically kind of walk you through the on-site process of what we need, and then if it's validated and it is a viable project, at that point we will send either a technician out to actually do a final walkthrough, so we can provide the final drawings and a final quote. But that's kind of the process, is just kind of reach out to us through that website. Generally the guys are turning it back around the web inquiry within a couple of hours, getting back to the consumer or the end user, and we generally can have a quote back to you within about a day's time of you providing that information to us.
Okay, great. Now, obviously, you find a great situation, you plug it in, energy savings, everybody's happy. From that point on going forward, what are sort of the maintenance items that you find in these type of equipment? So one of the ways that we built the system is we really had the ongoing maintenance in mind, and every time we make an adjustment to it, we look at where our fail rate was at the last component. Today, we actually, for those 10,000 systems, I'll tell you that we've got one guy that sits on the trouble line to answer those incoming calls. There's a 24-hour maintenance hotline that you can call if there's ever a project with a problem with the system. With one guy?
with one guy. Well, there are other people that are on it, but what my point in saying that is he mans that we don't have the need for just this massive call center.
Okay, but he sleeps.
We let him sleep. Okay, yeah, some days. Now, some days, it's just you got to get up and get to work.
Okay,
suck it up. But so the standard maintenance items are you're doing your hood cleaning. You want your hood cleaners to be aware that the system is there. Cover the optics with a piece of tape while they're cleaning the system. They just basically put it over the entry hole. They can spray the hoods down. It can get wet. That's fine, but we don't want that 3,000 psi pressure on there. We want to be conservative. And then taking and wiping the sensors down with a lint-free rag. Those are basically your two maintenance items. The system's pretty intuitive to where it's going to tell you if there's a problem with the system. The VFDs are going to report back to the processor, which is going to come up on the keypad and say, hey, you got an issue here. From a safety standpoint, if there's any problem with the system, it defaults to 100% to make sure that we are. If we can't see, or if our optics are blocked or whatever, it goes to 100% for the safest measure possible. There's not a lot of maintenance with the system designed that way, and because it's in a kitchen, we know what kitchens are like. They're busy. They don't have a lot of time to perform maintenance in them. If you look at the actual makeup on the website of the equipment, it's all high quality stainless steel. It's all UL listed with a kitchen in mind. And we really don't have a lot of maintenance options. I would say that generally, once every year, you want to kind of set up for a PM and then do a cleaning of the temp sensors.
Okay, so the temps, you wipe down the optical sensor at all, or
maybe once every 3 to 6 months.
But they don't get dirty because you have that positive pressure back in them.
That's correct. So what generally happens if they're getting dirty, it means that there's a failure in a fan on top of the hood. The system has a 3-year parts warranty on it, so that's if you contact us, we're basically supplying those components. And in addition to that, with from the maintenance perspective, if there's ever any manufacturer, if it's manufacturer defect or if it's installation defect, we're covering that obviously as well.
So the obviously, we have the detection. We're varying the speed. Variable speed drives. What brand are you using? Is it something that you've developed? Is it
Melink personally uses ABB and Allen Bradley just because of the protocols and the way we communicate. It's very simple. Now with the next generation controls that have just come out, we've made a couple of upgrades to where the optics are auto calibrating. So like we talked about cleaning them earlier, there's not the need to do that nowhere near as much now. But with the drives, another one of the upgrades are that we can communicate with many more drives. But if you are, call Melink and say what drives do you want to use, we're going to use either ABB or Allen Bradley, depending on your scenario.
Okay. And it's typically one drive per motor. Is that what we're,
Yeah, there are, yes. In standard application, you got one drive per motor. There are applications where you actually will see it's basically one shaft through two fans. There's some different types of setups out there that will have, more than one motor on a drive type thing.
Now, I guess if you had a system that had a VFD drive already, obviously you're gearing towards that constant volume market, but if there was a drive on it already, you'd rather just, bypass that drive, take it out of service, or can you link up to it, or what do you do?
Depending on what type of drive it is, if there's already a drive on it, more than likely we're going to try to communicate with it. We're not going to try to add cost to the customer unneedlessly. But if most of the time we are just adding some of our components to the drive, some wiring harnesses and other things, and changing the parameters, and we start communicating with it the same way we would with the ones that we supply.
All right. Anything that we haven't covered already?
Can't think of anything, Matt. I think we covered a wide range of it. I'd like to, again, I'm Jason Taylor. If you need any information from the website, just just ask for me direct, and I'll be more than happy to help in any way I can.
All right, great. Thanks. Thanks for Jason.
All right, appreciate it.
All right, from the floor of the AHR Expo here in New York City, this is HVAC 360. All right, and we're back. All right, thanks to Jason Taylor from Melink for giving us that tour of the Melink system. It's again, it's one of those things that's really it's fascinating. It's energy savings. It's one of those things that kind of slips through the cracks. So I like their solution that they bring to the forefront. It kind of simplifies things, makes things kind of automatic, and takes the energy savings and makes it more attainable for people. So I hope you enjoyed it. I hope you learned a few things. Again, thanks for listening. I appreciate each and every one of you. I'm trying to put these out, on a regular basis, but truth be told, it's going to be hit or miss here for the next couple of months. But I appreciate you, and I will try to feed you nuggets. I have a couple more that I just want to have some wrap-ups of the AHR Expo that I might pass on to you and some of the people that I talked to there. So for now, if you like the episode, please pass it on. That's really the best thing you can do for me. If you have a comment, you can shoot me an email at matt@buildingx.co, or you can put it in the comments of the show over at buildingx.co. That's the website where I host the HVAC 360 podcasts. Again, email me, Twitter me, BuildingX, and LinkedIn, Matt Nelson PE. You can befriend me there, link to me there. I always love to connect with listeners. All right, so that's it for this week. If you have any comments, shoot them that way. I gave you the contact information. And remember, always know what you build and share what you know.